Hi there, and welcome to this lesson on writing equations of lines. I debated what to title this lesson, and I ended up settling on introduction because actually the next several lessons are going to really expound on writing equations of lines because there's a lot of different ways we can do it and places we can start and places we can end a problem. And this one just kind of introduces the idea. So please like and subscribe for more math help. Drop a comment below. Let me know what you think of this video if you found it helpful. If you've got questions, I would love to hear from you about it. So why do we write equations? And this gets into the practicality of math. Why is math, why is algebra something that we need to study at all, really? What do people do with it? So a teacher can just give you equations and say, here, graph them. Why is a question a lot of students have. So why is this a skill that is worth developing? Well, many real life, and I put this in quotation marks here because I think real life, I don't want to make it sound like school isn't real life for you. It is like a real life situation, like your math class is the real world. So a lot of times we talk about real life, we mean outside of math class, like in my job or at my home, like who uses this? Why is this a thing? So many real life situations involve the process of writing equations, linear and otherwise. So we start with writing linear equations, and then as we develop more math, we realize there's a lot of different kinds of equations we can write, and you can spend courses on like algebra 2, pre-calculus, and so forth, figuring out how to write those from given data. So here's an example. For example, a scientist or financial expert, somebody who works in the economy, lots of people, whoever. Okay, so but we'll say a scientist, an engineer, a finance guru. Okay, they conduct a study and gather some data. All right, so this could be data about income, mortgages. It could be a scientific thing. If you've done a science fair, you're gathering data, doing research. Maybe you are in pharmaceuticals and you are running a study on a new drug that they want to put out there. Okay, you're conducting a study, you're gathering data. Then they look for a way to represent that data mathematically. Okay, so you've got this body of data, and now we're going to look at the data, and that data, we want to find out some stuff about it. Now, this mathematical representation is called a model. It's called a mathematical model or modeling something mathematically. And here's what you can do with it. You can evaluate how effective something is. So again, if somebody's putting a new drug on the market, we want to know, does this drug work? How well does it work? You're going to have to back that up with data, and that data is going to require a mathematical model, perhaps to predict future behavior. Okay, so you're going to look at that data and look for a trend. And what kind of a trend is it? Now, a linear trend is one of the trends you might have. Or determine causation or correlation of two events. Causation means that one event causes another event to happen. Correlation simply means that they are related events, but they might be caused by something else, where you have one trigger and it causes two different events, but you can establish that these two events are actually related to each other because they're caused by the same thing. So that's what you might do with the data. And you don't jump into that at the time that you get hired to be like the financial consultant for a company. You start in Algebra 1 looking at lines and figuring out, how do I take this data or these points or this information and modeling it with the equation of a line. And then we build from there. So we really want to lay a good ground, the groundwork for what you can do in the future, and develop the sense of, what am I doing? But this gives you a little bit of the why behind it. Why is this a skill that's in your algebra course? So this lesson is going to look at two types of problems, and we're going to build on this later. It's a very short lesson, and we're just going to look at kind of two ways to look at this, and then future lessons are going to go in, well, what if you saw this? What if you did that? How could you leave the answer here? We'll bring back some of my student data for one of the future lessons. So the first type you might see is writing the equation given the slope and the y-intercept, and I have a little bit more to say about that. So for example, write the equation of the line with a slope of -2/3 or -2/3 and a y-intercept of 5. Now, right here, I just want you to note a couple of the things because this problem takes about 15 seconds to do, but I want you to notice what goes into being able to do the problem. Note that this problem requires you to recall slope-intercept form of a line, all right? And that is y equals mx plus b. So we're drawing on a previous lesson. If you're like, I've never seen that before, I do not know what that is, stop the video right now, go back and check out my video on slope-intercept form, as well as the symbols and vocabulary for slope and y-intercept. So we need to know that the m value is the slope and the b value is the y-intercept. And without knowing that, you cannot do this problem. So let's take a look at it. It says the slope is, I'm going to time myself. Okay. The slope is -2/3. So the m value is -2/3 and the y-intercept is 5. And so my b value is 5, or you might see the point 0.05. Okay, so the x value is 0, y value is 5. And then we write down slope-intercept form, and then we simply plug in the numbers. So my m value is -2/3, and my b value is 5, and I am done. That took me about 30 seconds with the explanation and the rewriting. So about 30 seconds with that. Could have done it faster if I wasn't talking. Now, other things to note about this, as I was writing it, you do need to remember your substitution skills. So sometimes in Algebra 1, we just assume that students know how to substitute, but way back, if you need to dig through some of my older videos, go and look at a video on what it is to substitute, to take out a number, a variable, and put a number, or not necessarily a variable, but a letter, and put a number in its place. So that's the first type. The second type would be to write the equation given a graph. And this is something that a lot of students forget that they can do. There are some like dodgy things about it that you want to be careful of. But generally, like this is an underrated way of doing it. So looking at this one, you would first locate probably the y-intercept. And so the y-intercept appears to be right there. And so the y-intercept is the point 0, -4, or you might just see b is equal to -4. Now, here's where I said, like, it appears to be. When you're doing a problem this way, you always want to be mindful of the fact that maybe, just maybe, the line is really, really, really close to -4, but it's not exactly -4. Maybe it's -3.99999. You just can't tell. Is that possible? Yes. Is it likely? No. And so just always be aware of the directions, what your teacher might be asking you to do, and so forth. Now, to get the slope, we will simply count the rise over the run. So we're going to find 2 lattice points. So I'm actually going to pick them up here, not because they're better than what's down there, but because I'm not getting it like kind of cluttered with the labels on the axis there. So I went and found 2 lattice points, and I am going to count my rise and my run. So my rise is 1, 2, 3, and my run is 1, 2. And so using slope-intercept form, we have y is equal to, slope is 3/2, and the y-intercept is -4. You would also be correct if you wrote that as a subtraction sign. Okay, so that would be fine as well. Okay, and that again, you always want to be aware, like maybe, just maybe the graph is not accurate, but highly unlikely for that to be the case, especially in the early stages of Algebra 1. You can just look for it and find it. So key takeaways. What do you want to take away from this lesson? Very short lesson. What are the ideas that we need to take with us into future lessons? First of all, to write the equation of a line, you need to have two pieces of information. You need to know how steep the line is and where the line is located on the coordinate plane. So basically you need to know how steep and where do I put it. If you've got those two pieces of information, you will be able to write the equation of the line because there'll be only one line that goes through a specific point with a specific steepness. Okay, you need to pause the video and think about that for a second. Feel free to do so. Now, here's where it can get a little more interesting. You might be given the slope, which in these problems we are. We're just being given the slope. Or the information needed to find the slope. So that could be like from the graph, counting it off the graph. It could be given 2 points and you calculate the slope. Maybe you're getting the slope from another equation. Okay, so there's other things that you could be doing, but you need to have the slope. So you're either given the slope or you're given some information that will allow you to find the slope. And second one, you might be given the y-intercept or another point on the line. It doesn't necessarily have to be the y-intercept. So when I went and found the slope there, I like kind of moved around on the line and found the slope from a different spot. You might be given some other points, but if you have enough information, like where is the line? It goes through this point and this is how steep it is, then you have all the information you need to write the equation of a line. There are different strategies and forms we can use to accomplish this, and we're going to explore those in future lessons. So this one, just starting off, slope, y-intercept, put it into the equation. And then what we're going to do over future lessons is layer onto that. So what if you're not given the slope, but you're given this instead? How would you do that? What if you're given a point, but not the y-intercept? What can you do then? And we're going to kind of work our way through that, as well as go back to some actual data plots. I'll see if I can find some that my students have done and look at that and then see what they're doing with those data plots. All right, so that wraps up this lesson here. Please do not forget to give this video a thumbs up if you found it helpful. So if this cleared up a couple things for you, please let me know. Drop a comment, let me know what you think, and subscribe to the channel for more math help. Also, be sure to check out the practice set. I will link that in the description box so you can practice on these problems. All right, I'll see you in the next one.